All right, girls, I'm sorry. I don't know why the last video cut off right as I was making that calculation. I think it might have decided it wants a 15-minute limit on the videos I upload. So here, we were taking 7 plus root 85 over 6, and that gave us 2.703. That was 7 plus root 85, so we also want to do 7 minus root 85. So let's go ahead and do that in our calculators as well. 7 minus the square root of 85, that gives us negative 2.21. And divide that by 6, and we get negative 0.3699, or we could round that to negative 0.370. So those are our two solutions. But now remember that we weren't just solving for x, we were solving for the sine of x. So now we're going to have to perform two inverse sine operations. So we want to take the inverse sine of 2.703, and we also want to take the inverse sine of negative 0.370. Now, if I try to take the inverse sine of 2.703, we remember again that sine is only going to go between positive 1 and negative 1. So there's no possible value that would give me 2.703. So there's no solution from that result. So instead what I need to do is to take my inverse sine of the answer that we just got that was negative. So here what's easy to do is if I just inverse sine the answer I got, my result is that my x value is equal to negative 0.379. Now, here's where there's a little bit of an issue with the way we want to report our answer, because most of these problems, although it wasn't clearly specified at the top of this problem, are going to ask you to report your solutions, again, where your theta or your x is in between 0 and 2 pi. And remember, 2 pi is 2 times 3.14. So if we're thinking about this in approximated radians, it has to be in between 0 and 6.28. Negative 0.379 isn't in between 0 and 6.28. So this is where we have to think back to when we first tried inverse sine problems and we had to think about our different quadrants on the unit circle, or just our different quadrants when we're thinking about sine and cosine. So let's go ahead and make an xy graph here. So if we think of our circular reference frame, remember this is 0 and 2 pi. This is pi over 2. This is pi, and this is 3 pi over 2. So my angle value of negative 0.379, that's right here, is really just going counterclockwise this direction, negative 0.379. So there are a couple of ways that I could figure out what that value should be, but probably the easiest way would just be to go from 2 pi and subtract that value. So if I have 2 pi, again that's 6.28, so one of my solutions would be 6.28 minus 0.379, because this is my 2 pi right here, and I've gone down negative 0.379. So if I want the positive angle value here, I'm just subtracting that from 6.28. So if I do that, 6.28 minus 0.379, that's going to give me 5.901. So one of my x values is going to be 5.901. Now I say one of my x values because typically in a circular reference frame, remember that we can have more than one angle value that results in the same sine and cosine. And the way that we can find that is by considering where our trig functions are positive. So all of my trig functions are positive here. My sine function is positive here. My tangent functions are positive here. And my cosine functions are positive here. So we already found 5.901. That's over here in quadrant 4, where only my cosine is positive. So there's going to be one more angle on the unit circle that also results in a sine value of, when I take its sine, that gives me this expression of negative 0.370. So what I need to do to find that expression is to consider where else is sine going to be negative, because I have a negative result here. So all of my angle values are positive here, so it's not going to be in quadrant 1. All of my angle values are going to be, my sine values are going to be positive here in quadrant 2, and I'm taking the sine, so I can't use that one. So that means that this quadrant over here in quadrant 3, where just my tangent values are positive, is going to be the other place where I have a negative sine. So what I want to do is to find the angle who has the same reference angle as this over here. So that means I'm going to have negative 0.379 here, or 0.379 here. So this value will be equivalent. This will be 0.379. And so in order to get an approximation of that value, I can take pi and add it to 0.379. Now if I want to approximate this, pi is 3.14. And so then if I add 0.379, I'm going to get, let's plug that into our calculators, 3.14 plus 0.379. That will give me 3.519. So this is one of my x values, and this is my other x value. So this quadratic has two results because of the fact that there are multiple angles that give me this same sine value. So I have to work backwards. Now, if you found that tricky with the reference angles back when we first looked at it with our inverse trig functions, it would be worth going back and reviewing that material before solving your quadratic expressions, because you'll probably have to do this most of the time with the examples that you come across. So let's take a look at a couple more examples together. And the next one that we're going to do, I think may feel just a little bit tricky the first time you see it, but it's not too hard. It just requires some thoughtful insight about what trig functions we're working with. And so our second example here